Hello students. So our next topic is working of ANN. So at the end of the session, you'll be able to understand the working of artificial neural network. Okay. So this is just a structure of artificial neural network, which we have already discussed in our previous videos. Okay. So this is a multi-layer neural network. So this multi-layer neural network consists of input layer, output layer, and hidden layers. Okay. So hidden layers can be more than one hidden layer. I hope everyone is clear about this part, okay? But whereas the input layer and output layer has to be only a single layers, but hidden layers can be more than one. Okay, in this particular diagram, I have considered input layer with three neurons, one hidden layer with two neurons, and a single output. So theoretically, how ANN works means, so we will be giving input to the input layer. So from the input layer, that our input will be traveled to the next layers, nothing but hidden layers. And in the hidden layers, all this information will get processed. Okay, so information will get processed, and from the output layer we will get the output. So theoretically this is how a typical artificial neural network works, but mathematically speaking we have a formula to calculate the output of ANN. So that formula is a summation of xi into wi, which means, so here I have considered a single layer neural network. These are not hidden layers, okay? Don't get confused. These are not hidden layers. I have just represented the working like this, okay? So here I have considered m neurons in my input layer, x1 to xm. So as you all know, each and every connection will be associated with a certain weight, right? So weights also W1 to Wm. So here first step will be in the input layer, we will fed all the inputs and then we will initialize the weights. So this is the first step. First step. So second step is we have to calculate a net input signal. This is very important step. Okay, so we have to calculate net input signal. Net input signal means, so first we will multiply all the inputs with their corresponding weights. So that means what will happen here, x1 into w1, x2 into w2, x3 into w3, up to so on xm into wm. So this is the summing junction. So here first step is we have to multiply all the inputs with their corresponding weights. So after multiplying all of them, we have to aggregate. So this is the summing junction. We have to aggregate them. Aggregate them means just we have to add them. Okay, add all the multiplied signals. That means x1 w1 plus x2 into w2 plus x3 into w3, up to so on xm into wm. So this is the summing junction. Okay, I hope till now everyone has understood. So the second step is we have to calculate net input signal. Formula for that is summation of wi into xi. Okay, so for example, if you are using a bias is nothing but just it is just an additional parameter sides weights that we use. So generally bias value will be equal to 1 only. Okay, so if in case if you are using bias, this is just to adjust your output. Okay, it is just an additional parameter. In case if you are using bias in your neural network, that bias value will be 1. Okay, so anyways, this is the formula, x1 to w1 plus x2 into w2 plus x3 to w3, which means here we have considered only 3 neurons and 3 weights. So this is the formula to calculate net input signal. So till now we have calculated net input signal. You can represent it as y in or y sum. Okay, so after calculating net input signal, that is just our partial output. Okay, that is not the final output. So to get the final output, we have to apply a function called activation function. Okay, so next step is, to this net input signal we have to apply a function called activation function. Okay, So after applying activation function, then only we will get the final output. So there are different types of activation functions which we'll be discussing in our next sessions. Okay. Um, right now, remember, to get the final output or to activate the final output neuron, we have to apply activation function. Okay. So like for example, I will just give one example. Okay. For example, if I want my output to be in a binary format, like for example, yes or no, like 1 or 0. So in those cases, I have to apply a activation function called binary activation function. So I have a binary activation function. So if I apply a binary activation function here, then my output will be either 0 or 1, or either this or that. So after getting final output, now next step is we have to check whether there are any errors in the neural network. So error is nothing but desired output minus predicted output. That means we will actually have desired output. That means we will have idea about how our output wants to be, how we want our output to be. Okay. So if our desired output is not equal to the output that we have gotten here, that means that we have error in our neural network. Okay, so error is nothing but desired output minus predicted output. Predicted output means the output that we have gotten here, that we have predicted. Okay, so if those two values are different, then that means we are having error in our neural network. Okay, suppose if I want my output to be 1. Okay, that is my desired output. 1 should be my output. But after calculating all these things, if my output is 0, so desired output is 1, but my predicted output is 0. Both of them are not equal. That means I'm having an error in my neural network. So in those cases, I have to rectify those errors. Okay. So to rectify those errors, I will be using an algorithm called backpropagation algorithm. And again here we will retrain our model. That means again we will process the neural networks again. Okay. So here we will process our neural network or retrain our neural network until we get the desired output. Until there are no errors in our neural network, until then we will retrain our model. So this is um, how neural networks work. Okay. I hope this session is clear. Our next topic is building blocks of ANN. Thank you.